Hey everyone, sorry I'm a bit late. Had a meeting, ran a bit late. Okay, so it's not 1 o'clock yet, but let's go ahead and get ready. Okay, so first group we have today is ASME versus Hydro level 4. I think this was Sam's group, right? Is everyone there?
Yeah, well,
I'm
I'm here.
here.
Okay, let's see Wissam. Who has the slides?
Um,
We can we like
I
switch between screens? Because we all have like a unified set of slides. Or
Um, what do you mean by that? So multiple people are going to be sharing their screen?
I can just run the slideshow if needs be.
Okay, let
I'm
me give
happy to.
you. Okay, let me make you co-host. Okay,
All
good.
right. All right.
Hang on, let me set the timer. We're gonna let's wait till 1 o'clock before we start too.
for sure.
All right, it's 1 o'clock. Let's go and get started. All right, good afternoon, everyone. How's everyone doing today? Hang on, someone calling me.
pretty good.
Okay, hang on. Okay, so just like Tuesday, we have a final presentation set for today. We have four groups on deck. So first we have ASME versus Hydro Level Corp. Second group going today will be Space Shuttle Challenger. Third group will be Aberdeen 3, and the last group will be the Titan Submersible today. Okay. All right. So same time limit as last time. So you groups will have 18 minutes to present. I'll send warnings in the chat when you're down to 10 minutes, 5 minutes, 2 minutes, and so on. And just to make sure we have enough time for everyone, I will probably cut you off once if the time runs out. Okay. All right. So yeah. So we have our first group already. So whenever you guys are ready, I'll start the timer when you flip the first slide.
All right. Good morning, everybody. My name's Joe, and this is ASME versus Hydro Level.
All right. So I'm begin. So conflicts of interests, they happen all the time. They have happened and they will continue to happen. It's just kind of the sad reality in a lot of industries that you can't really escape no matter how big the company is. Very special example right now is actually Boeing. But there is a very peculiar thing about this case that is very interesting. And it has to do with the fact that it's not from what you would expect. We usually call upon a bigger brother, like a nonprofit organization, a committee, or a government to help us, you know, even out the playing field and play the goalkeeper. But with here, this turned out to fail us. And next slide. ASME was the one in question here. They are one of the largest engineering organizations in the world, if not the largest, with 90,000 staff and $120 million of a yearly budget. But as you're gonna see, next slide. This is the first time that we've had a conflict of interest breach within something of this scale with or a society like this. So founded in 1880. When this happened, they've built a reputation of almost 100 years of service. And, you know, for the what's going on right now, I mean, at the time, McDonald and Miller had sort of a monopoly when it came to low water fuel cutoffs. They were in the boiler business and they were just completely wiping everyone. Until another company called Hydro Level wanted to enter it and be the kind of like the underdog to challenge them. Next slide. So Hydro Level had their own invention, which was to include a low fuel, water fuel cutoff with a delay timer. So with their new innovation in this, they sent an inquiry to ASME's Boiler and Pressure Vessel Committee to ask if it met the requirements. And oddly enough, before they could send theirs, they had already gotten an interpretation of it. So that's a little bit weird. They haven't even asked for it, and they kind of gotten an interpretation of it that assumed that their system would not be non-compliant. So, I mean, next slide. This all seems weird until you see the personnel involved. It turns out that John James, president of McDonald and Miller at the time, was also vice chairman, petitioners subcommittee of the ASME. And when he was at the time there, he actually sent the request for the codes to see if it was compliant. And Eugene Mitchell at the time was part of the sales, and um, I mean,
I'm
sorry,
happy to take this part.
yeah, I edited.
Yeah, no problem.
Eugene Mitchell sent the idea to John James, and he was also involved in ASME's Boiler and Pressure Committee. T.R. Harden was part of the sales team for McDonald Miller, and he's the one who gave the idea to the both of them to do it. So what they did as a team was sort of send a request for the interpretation to see if it was compliant, just so they can kind of reword the inquiry and make it seem that hydro levels was completely not up to the code. It's essentially sabotaging. Now, this is pretty big at the time for hydro level. Next slide. Because at the time, hydro level actually had a huge deal with Brooklyn Union Gas Company. They acquired a nice contract to them that McDonald and Miller originally had, and you can imagine they weren't happy about that. And on top of that, it was the 1970s where you had the looming oil crisis and a lot of urban renewal projects. So the demand for boilers and more efficiency was at an all-time high. You know, so at the end of this entire thing, Hydro Level ended up facing bankruptcy, and they could never get into the market because of it. And it was only until 10 years later in 1981 when the court case happened when they finally got their justice in the form of $4.75 million. Next slide.
Oh, the AS the ASME versus Hydro Level Corporation case highlights an ethical dilemma centered on industry standards and conflict of interest. ASME was tasked with ensuring mechanical device safety, faced manipulations by McDonald and Miller executives who aimed to undermine Hydro Level's product. Leveraging ASME's influence, they biased recommendations against Hydro Level, prioritizing company gains over professional integrity. This breached the trust of engineering principles driven by desire to maintain market dominance and revenue, neglecting fair competition and consumer welfare. Next slide, please. Comparison with ethical framework. From a utilitarian perspective, the fraudulent conduct of individuals within ASME resulted in significant harm, both financially and reputationally, to the organization and its stakeholders. This unethical behavior prioritized short-term gains for a few individuals over long-term well-being of the organization. In deontological ethics, which emphasized adherence to moral duties and principles, would condemn their fraudulent conduct as a violation of fundamental ethics principles such as honesty, integrity, and trustworthiness. Next slide, please. The IEE Codes of Ethics violation of Principle 1, which states to maintain the highest standard of integrity and professionalism. And Principle 2, which is to treat all persons with dignity and respect. And Principle 8, which is to avoid injuring others, their properties, reputation, or employment by false or malicious action. The NSP Codes of Ethics, Violation 1, which states that engineers should hold paramount to safety, health, and welfare of the public. And Canon 3, which states that engineers shall issue public statements only in an objective and truthful manner. Next slide, please. The ethical issue in this case has significant impact and fallout on the company and individuals involved. The companies and individuals involved were Hydro-Level filed a suit against McDonald and Miller, ASME, and the Hartford Steam Boiler Inspection and Insurance Company, charging them with conspiracy to restrain trade under the Sherman antitrust law. ASME faced a trial where it argued that it should not be held liable for actions of individuals' volunteer members. The financial impact, Hydro-Level reached an out-of-court settlement with McDonald and Miller and Hartford for $750,000 and $75,000, respectively. The jury decided against the ASME, awarding Hydro-Level $3.3 million in damages. The trial deducted $800,000 in prior settlements and tripled the remainder in accordance to the Clayton Act. And the end result was $4.7 million in as a settlement for Hydro-Level. The media coverage. The case garnered media attention due to its impact for antitrust violation and the power dynamic of organizations like ASME. The controversial 6-3 vote by the Supreme Court added to the media interest, particularly with Justice's opinion highlighting ASME's influence on the economy and its potential to frustrate competition. As a result, ASME now requires all staff and volunteer committee members to sign statements pledging their adherence to a comprehensive and well-defined set of guidelines regarding potential conflicts. ASME also now provides all staff and volunteers with copies of engineering codes of ethics along with publication outlining the legal implications of standards activities. Next slide, please. An alternative course of action that the individuals involved in this case study should have taken is to prioritize transparency and proactive measures to prevent fraudulent conduct with the organizations. Specifically, they could have implemented robust internal controls, ethical guidelines, and compliance mechanisms to detect and deter unethical behavior. Next slide. This course of action would align with several principles outlined in the codes of ethics, including integrity and honesty, professional responsibility, avoiding harm, and finally, continuous improvement. Next slide.
My part is about outlook for future situation. I already put it on here, but I'll run through something. There's an increase on emphasis on transparency, which have more screening, more because with higher emphasis in decision-making process, we have more stakeholders in review because it's not going to influence the whole cohort or even organization, and more documents should be reviewed, and then with public announcement to promote accountability for that. And then with stricter conflict of interest policies, there's mandatory disclosure, regular training on ethical conduct, which is really important for engineering professionalism, as well as enforcement of policy, and then with stronger process to prevent unethical in decision making. Next slide, please. There's total of six. So the third one is legal awareness. Companies should check more with their legal department with to check with liability issue and antitrust law, and then more legal action should be reviewed, and then with legal expert in their company or outside, we will have more ethical uh organization, and then there's improvement in ethical education. uh Engineering should be trained and educate about professionalism in their field, as well as value integrity and ethical conduct. Next slide, please. And then the last two one is technological advance. Um, we can have more of that since most of the incident happens around when paper is not clear. There's no digital form or platform that have all the conducts, that have all the requirement, that have all the checklists. So we should have a technological advance in the situation. And then with the global harmonization of standards, we all have our standards that connects company and organization together with the open market and promote safety and quality standards worldwide. Next slide, please. For conclusion and summary is valuable insights into future trajectory of standards management, unclear policy, legal awareness, ethical education, and global standardization within professional organization, which mean is we should have our own standards for our company around the world. Mostly is in our market since we're all in professionalism engineering. And the moral of the story is we need to talk more, we need to communicate more, we have more common ground, and we unite in purpose. Um, that's all. Thank you.
Great, thanks, guys. That's really well done. Let's give this group a hand. I say that, but I realize we're all on Zoom, but I assume you guys are all clapping with your mics off. Okay. So next we have a Space Shuttle Challenger. So Tian, Nguyen, Mohammed, Crystal, Karthik, are you guys all here?
Yes. So how are we doing this?
Or a second?
How are we going to are you gonna share it or give me permission or?
Yeah, you have the slides, Crystal?
Yes.
Okay. All right, go ahead.
Am I in charge? Let me see. How do I share this? Hold on.
Yeah,
Technical errors. Wait. Oh my gosh.
Yes, so
Yeah, to share,
we're outside and it's hard to see my screen.
Oh, okay. Yeah, there's a green button on the bottom of Zoom that says share screen.
Yeah. Where'd it go?
I need that full screen.
Well, I have to make this full screen though.
Okay.
Well, let's find out. Share. Sorry, we're here.
No worries, no worries.
Okay. There we go.
Cool.
Okay.
Looks good. All right, whenever you guys are ready.
Thank you. And here we go. Okay, so our project is 73 seconds, the Challenger disaster, an engineering ethics case study. This is just a brief video.
3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower. Three, two.
So the Space Shuttle Challenger was NASA's 25th mission of their Space Shuttle program. It was the 10th and final flight of the Challenger. It exploded and broke apart 73 seconds into flight. 7 people were on board and lost their lives. Of the 7, 1 was a non-astronaut civilian. She was a teacher. The explosion was caused by the failure of an O-ring seal in one of the solid rocket boosters. The weather conditions that day were what contributed to that failure. Flaws in the decision-making process and communication within NASA were later revealed to be large contributing factors. And this disaster highlights the importance of rigorous safety protocols in engineering and beyond. This is the crew of the Challenger. I believe all the people here, except for one, which is Krista McAuliffe, had been to space before, at least once. They were pilots and engineers and were familiar with the process. These are their names and their roles. So this is Commander Scobie, Pilot Smith. Mission Specialist 1 was Ellison Onizuka. Judith Resnick was Mission Specialist 2. Ronald McNair was Mission Specialist 3. Krista McAuliffe was the teacher in space, and Gregory Jarvis was payload specialist. August 27th, 1984, President Reagan announced the Teacher in Space project with the first private citizen flying into space. His goals were to inspire more interest in science, math, and space. It was originally planned for July 1985, but it was delayed due to changes in the payload. It was pushed to December 23rd, 1985. And then there was another pushback to January 23rd, 1986. And then subsequent days after that until January 28th, 1986 was going to be the official launch date. And it mainly had to do with the weather at the time.
Okay. Can you guys hear me?
Yes.
Okay, great. So I'll cover the technical context. So the night before the launch, it was the coldest recorded temperature at the time at Cape Canaveral, and there was a good debate on whether or not the launch should take place. And the main debate was around the O-rings on the solid rocket boosters. And before the launches, they would inspect, or after each launch, they would inspect each component of the boosters, and they found that the O-rings would get worse and worse as the launches kept going on. And the engineers over at KSE or KSC and NTI strongly recommended that NASA not go through with the launch. But NASA was also under extreme pressure from the US government to continue with it, and they said to go forward with it. In fact, it was so cold that ice had formed around the launch pad, and it was a concern at the time, but as it got warmer throughout the day, they said that it was no longer a factor. You can go to the next slide. There we go. Yeah, So on the eve of the launch, engineers at MTI decided not to go, but at the end it was decided that the analysis from the engineers was not conclusive enough to delay the launch again. And right here you can see that pretty much as it got colder, the O-rings would not perform as they would. And it's kind of like a rubber band. When you stretch it when it was warm, it's very elastic, but like let's say you put it in the freezer for like 30 minutes and you try to stretch it, it's not really the same. So it wouldn't really keep the fuel in the tank or in the booster, and it would just pretty much cause a catastrophic failure, as the O-rings would stiffen up as it got colder. And since this was the coldest launch that the space shuttle would have to do, there was a great concern about that. You can go to the next slide. Yeah, so NASA estimated that the returning system, it would be a safe launch, and they thought that they would plan to modify it after this launch. So yeah, yeah, they estimated the costs already to fix it, but as they were under much pressure, they decided that they would do it pretty much afterwards, after the launch, and they thought everything would go great. You can go to the next one.
I'd just like to say that this is actually from the Congressional Budget Office. This was after the explosion had occurred. So this is basically what they estimated, the CBO office estimated that it would cost NASA to return the system to a safe operational state after modifications. So it would have been 50 million in 1986, which is 142.5 million today. And the modifications combined with the cost of the investigation would exceed 350 million in 1986, which was almost $1 billion today. And then the replacement cost of the orbiter and all the spare parts for the orbiter over the next 4 years would have been almost 7 billion in today's dollars.
So the Challenger was manufactured by the Rockwell International for NASA, and Rockwell International worked with several subcontractors to manufacture different parts for the shuttle, including Grumman, Lockheed, and MTI. And from Rockwell, there was one personnel who was head of Space Transportation Division, and his name was Rocco Petron. And from MTI, there was 3 personnel. Alan McDonald, who was director of the Space Shuttle Solid Rocket Motor Project, and Joe Kilminster, who was vice president of the Space Booster Programs, and Robert Lund, who was vice president of the engineering. And from NASA, there's also 3 personnel too. Lawrence Murray, who was manager of the Solid Rocket Booster Project, and Arnold Aldrich, who was mission management team leader, and George Hardy, who was the manager of the NASA. You can go to the next one. And per NASA's regulation, it was the responsibility of the contractor to demonstrate launch readiness of the components. And any inconclusive data automatically result in a launch to be delayed or canceled. However, NASA managed Barry Murray and George Hardy informed MTI that they can only make recommendations and they want to go ahead with the launch. And you can see on the right side, that is a report talking about the temperature for the O-rings. It's basically saying that there isn't enough evidence to cancel the launch, even though the engineers strongly recommended to cancel the launch. And because of they ignored it, they unfortunately made a history.
Some of the codes that were violated during, or the codes of ethics that were violated were the IEE code I1, which is to uphold the highest standard of integrity, responsibility, and ethical conduct in professional activities. And the one part was to maintain the safety and the health of the public and to disclose any endangerment to the public. And in the NSPE code, I2 is the rules of practice for engineers to hold the highest amount of safety for the public, health and welfare. And the A part is the engineer's judgment, or if the engineer's judgment is overruled under circumstances that endanger life or property, they shall notify the employer. And it was a violation because NASA's management ignored the warnings of MTI engineers, and they went ahead and continued the mission beside. Yeah. So some of the impacts. The investigation that followed revealed that there were flaws upon the decision-making of the process and communications within NASA. It highlighted the importance of rigorous safety protocols in engineering and safe space exploration. The Challenger's disaster led to a temporary suspension of the space shuttle program and prompted an evaluation of safety procedures. It had a broad implication for the perception of space travel and served as a reminder of the inherent risk involved in space travel. So, a commission was formed through William Roger, and it involved.
Oh, no, sorry. You can't see the.
It was written by a presidential commission charged with investigating the Space Shuttle Challenger. The chairman was William Roger and included Neil Armstrong, Sally Ride, and other prominent astronauts and engineers. They identified factors that could cause the problems of the accident. So they looked through the crash site, they checked the launch pad, the external tank, the main engine, the payload, and solid rocket motors and solid rocket boosters. And then the commission recommended NASA to form a safety division to improve their landing safety, set up a launch abort, and other escape options, and extensive testing of materials.
I never seen it.
Can you hear me? Hello?
You're good.
Yeah, okay. For the future outlook, for disasters similar to the Challenger, emergency plans should be implicated on the space shuttle to ensure the safety of the astronauts. NASA failed to prepare an escape plan for the astronauts in case of a disaster due to the limited time and budgeting that they faced. The outcome could have been better if they have avoided the risk of the astronaut and prepared the space shuttle rather than taking the risk of it flying. Next slide. Next slide. Necessary changes had to be made by NASA. They needed to transition their safety analysis from focusing on worst case scenario, like a single worst case scenario, into multiple possible failures. A top-down integration system that viewed the analysis of the whole system, and a bottom-up that viewed the subsystems and separate elements that could fail. Next. The committee also recommended for the management and risk assessment to be more stricter, especially with safety. They required names and position of everyone responsible for every final decision. They recommended to establish an agency dedicated to ensure the safety throughout both the development and design process to get a good or enhance the decision-making process and improve the communication between management and engineering to discuss any risks or concerns that they could have. Next. As a conclusion, NASA established the safety reporting system in 1987 after the Challenger disaster. Those channels allowed anonymous reports to reach the upper management of NASA to report any concerns or hazards that could be either avoided or forgotten about. The Challenger disaster serves as a reminder for the importance of robust engineering and the safety protocols and ethical decision making. The incidents could have been avoided and human lives could have been saved have they not risked any small components similar to the oil or O-ring and the gas chambers. Thank you.
All right, thanks everybody. Or thanks guys. Go ahead and let's give them a hand. Okay, next group we have is the Aberdeen 3. Everyone here for that group?
Yep.
Okay, who's sharing the slides?
I'll be.
Okay, let me go ahead and give you the co-host. Oops. All right, go ahead. Okay, looks good. All right, give me a second. Let me get your guys' rubric ready. Okay, I'm gonna set the time for 18 minutes, and whenever you guys are ready.
Great, sounds good. Hello, everyone. This is our case study on the Aberdeen 3. So the introduction for the case. At the Aberdeen Military Proving Ground in Maryland, there were 3 chemical engineers that were convicted of a criminal felony for illegally storing, handling, and disposing of hazardous waste. They were just very negligent with all of the supplies they were using for chemical weapons. When the infractions were discovered, an inspection team came because they saw that there were dozens of fish dying in the river. After the inspection, the 3 high-level civilian managers were found in violation of the Resource Conservation and Recovery Act, and they were sentenced to 1,000 hours of community service and 3 years probation each.
In 1976, Congress passed the Resource Conservation and Recovery Act. This act focused on the protection of the natural environment and humans from hazardous waste. And like stated before, Aberdeen Proving Ground is a U.S. Army facility that was used to develop, test, store, and also dispose of chemical weapons. And it's been there doing this since World War II. Aberdeen had a history of having unsafe work environments and reports of chemicals being contained improperly since World War II. And then the events of the Aberdeen 3 case took place between 1983 to 1986. The 3 engineers who played major roles were Carl Gepp, William D., and Robert Lentz. And in 1985, there was a contamination in the nearby river, and it was estimated that around 200 gallons of sulfuric acid had leaked into the river. State and federal investigators found that the chemical retaining dikes used were not fitted properly, and much of the system used to move the chemicals were corroded, so they were way beyond their product life. And storage of the chemicals at Aberdeen were also mishandled. Many flammable and cancer-prone chemicals were left unsealed, and on top of that, chemicals that had mixed together, becoming lethal, were often stored next to one another. These issues were left unattended because the engineers believed that they were practicing good ways to handle their waste. So they felt that it wasn't necessary to do anything above this.
Economical context. While this case study doesn't have a large economical impact, it does result in having some key points. First being the project's budget. Now, the engineers were mindful of the budget that they were given, and is one of the reasons that they left the hazardous waste to save money, aside from them following their protocols. But all they had to do was request the Army for a cleanup fee, and the waste would have been dealt without them having to go into their budget funds. Now, they didn't do this, which resulted into having the environmental damages. All engineers were charged with fines. It was roughly around $750,000 that they were charged. In present times, that would be roughly around $2 million. Next slide.
Three high-level civilian managers were played major roles in Aberdeen. They were Carl Gepp, Robert Lenz, and William D. The three managers were in their early 50s at the time. William was a chemical engineer and a developer of the binary chemical weapon. Carl was a manager at the pilot plant where they developed chemical weapons, and Robert was involved in the process design for chemical weapons manufacturing. The trio claimed that they did not know violating the rules of the RCRA was a crime and were unaware the chemicals they managed were hazardous. Even though safety inspectors warned Lenz and Gepp about their improper storage of waste, and many employees complaining to Gepp about the chemicals, they did not do anything to address the issue. With multiple warnings about future chemical hazards in the pilot plant, the managers did not consider the problem a priority. Motivated by their work and nothing else, they failed to attend to issues and properly handle chemicals, which resulted in spills and their lawsuit. William was found guilty of breaking the Resource Conservation Recovery Act by illegally storing and disposing of hazardous waste. Mr. Gepp and Mr. Lenz were convicted of 3 felony counts of unpermitted storing, treating, and disposing of hazardous waste at the pilot plant. The court then suspended their sentence and placed each on probation for 3 years with the condition of 1,000 hours of community service.
So the ethical lapse with these 3 chemical engineers was that they worked at the facility for over 20 years. Inspections in 1983 and 1986 found leaks in the drums of toxic substances, chemicals stored in the same room that were lethal if mixed, and several flammable and dangerous chemicals left in the open. They knew they were working with dangerous chemicals because they were creating bombs, and even after this, they did not follow proper procedures. So to the right is the pH levels of the river running alongside the plant after the investigations were done.
The actions caused by these individuals violated the IEEE Code of Ethics, specifically Subpart 1 of Part 1, which states, to hold paramount the safety, health, and welfare of the public, and to disclose promptly the factors that might endanger the public or the environment. They were more interested in trying to maximize their efficiency than to keep people safe or to keep the environment safe. And this was mostly due to their stubbornness and lack of consideration for public safety, because RCRA, the Conservation Act, had already been in place for about a decade at this point, but they claimed during court that they thought they were not included in that because they were federal employees, because they were working for the Army. When in reality, they had safety inspectors come and tell them that their practices were not okay. Moving on to the impact. The next slide. One of the main turning points that caused the investigation was the sulfuric acid spill. And this is because it's extremely corrosive. And as already said, 200 gallons of it had spilled into the bay. As you can see by the safety data sheet I have on the left, sulfuric acid can cause blindness, tooth erosion, GI disturbances, dermatitis, and all these health effects that don't just affect the animals in the area, but the people working there and living there too. But even before the spill, they had so many health violations. They had 174 drums of burned chemicals. They had a bunch of asbestos and sludge from chemical waste treatment. And all these things were either buried in landfills, put into sewage treatments, or put into landfills in general and just completely not disposed of properly, which caused long-term health effects on the families living in the area and the workers too. Moving on to how this affected the engineers on the next slide. They were all heavily fined, but none of them served jail time and only had probation and community service, despite the max time being 15 years. And the pilot plant was shut down, but normal operations continuing to expose these families and these workers to these unsafe conditions. And at the time, the case received a lot of attention. Like, this was one of the few newspaper clippings I found. But since then, it has been mostly swept under the rug, very similar to the BP oil spill.
So other possible ethical choices that these three engineers could have made was to make sure that as soon as they started working there, that the workplace was organized, everything was labeled correctly. This would have avoided a lot of problems for them later on. Even before the law was put in place, this was just standard ethical chemical practices. And this would have been more in line with the IEEE Code of Ethics, where it says to uphold the highest standards of integrity, responsible behavior, and ethical conduct in professional activities, specifically the part that says to disclose promptly factors that might endanger the public or the environment. They could have done this by disclosing it to the Army and telling them that there was problems.
Outlook for future situations. If another accident like this occurs, it can have a long-lasting effect on humans and the environment. The chemicals spilled are hazardous and can contaminate the area around it. The effects on humans can cause illnesses or even death. Taking the time to address issues, preventing accidents from occurring, and learning what you're handling can prevent future situations like Albertine. Next slide. Due to the poor handling of the chemicals, there were spills in the pilot plant and in the nearby river. This led to the increase in cost because money had to be used to clean up and treat the chemicals. Addressing the issue sooner would lead to less money being used to clean up and more money elsewhere.
Now, to put everything in perspective, this case study addressed the Aberdeen Three, which were three chemical engineers in charge of chemical weapons that didn't properly dispose the leftover hazardous material that they were dealing with. Now, this resulted in environmental damages to the surrounding areas. This case study can prove that when dealing with certain materials, that doing the right procedures is important to the safety of the public and the surrounding environment. Understanding that there is laws to protect the environment, such as the Resource Conservation Recovery Act. Now, looking to the future, knowing that certain materials can affect habitats, it's important to set aside a budget for proper waste management and to know that the environment which the materials is being left at can withstand the waste for the certain amount of time that is needed to, and to understand that the public safety comes first. And that's our presentation. Thank you.
Great, good job, guys. All right, let's give them a hand. Okay, all right, so the last group that we have today, we're making great time today, is the Titan submersible. So is everyone here from that group?
I think so. Can you hear me?
Yep. Brandon,
right.
are you going to be sharing the slides?
Yes, I believe so.
Okay, let me go ahead and make you
That out.
co-host. I guess while they're setting up too, let me just make an announcement. So after class today, maybe sometime during office hours, I'm gonna open up an assignment on Canvas for you guys to submit your slides. And so I only need one person from your group to submit the slides. I'm gonna take just one last look at them and you know, before I release the grades for them. And I'll give you guys your grades before the weekend, probably sometime tomorrow. Okay, so just keep an eye out for that. You know, just because everyone will have presented after today, you know, I'm going to set the due date for the slides to be tomorrow. So just make sure that, you know, whoever's in charge of the slides in your group uploads the slides to Canvas, you know, sometime tomorrow. Okay. All right, cool. So we have one more group today, Titan Submersible. So looks like it's all set up. So whenever you guys are ready. Oh, did Brandon disconnect?
Hello, can you still hear me?
Yep, I can hear you.
Okay,
Did you
yeah.
disconnect?
Yeah, no, it crashed. I'm in my car right now.
Oh, okay. So does someone else on your group have the slides, maybe with a more stable connection?
Let me see. I can try again.
Is everyone there, or who's where are the others in your group?
I know one person's on a phone right now, and
I can try.
all right.
Okay, Anthony, why don't you try sharing the slides?
Are we good to go?
Okay. Yep. Whenever you guys are ready.
Yeah. Okay. So we decided to do our presentation on the Titan submersible. So change slides, please. So it's pretty well known at this point that the ocean has been less explored compared to space, and even the Titanic itself has remained a mystery for about 73 years before becoming a popular tourist destination for the elite and high ups. While space exploration was largely funded by federal contracts, nautical exploration, meanwhile, is still largely privatized, with some of these private exploration vehicles having questionable engineering to say the least. OceanGate was actually one of such private contractor which operated Titan to the Titanic for quite some time. And during one such trip to the Titanic, Titan lost contact with its mothership with about 1 hour 45 minutes into the trip, with the fate of the submersible remaining a mystery for about 4 days. So can we change slides, please? So about date 6/18/2023, the Titan descended on a routine trip to the Titanic, with its passengers including OceanGate CEO Stockton Rush, Hamish Harding, Paul Henry, I'm not going to try to pronounce that, and Shadaza Dawood and his son Sulman. The sub typically dove at about 55 meters per second to about a depth of 12,500 feet, and pressure at that depth was about 366 atmospheric pressures. Communication between the Titan and its mothership was done, of all things, by text messaging, since there was no GPS or signal down there. And the sub was supposed to radio back to the mothership every 15 minutes or so. However, its last status update was about 11:57 a.m. on that day. The Coast Guard, meanwhile, wasn't notified of the Titan's disappearance until about 7:15 p.m., which was hours later. And it's now known that the Titan sub's carbon fiber hull imploded due to compressive forces down where the Titanic is. So can we go to the next slide, please? So a little bit of history about OceanGate. It was founded in 2009 by Guillermo Stolzenhain and Stockton Rush in Seattle, and they wanted to specialize in 5-seater submersibles. The first sub that they had was acquired, not built, and it was named Antipodes. Its hull was comprised of steel, and it was largely successful, completing 130 dives and even partnering up with the University of Washington for experiments. As a private contractor, customers paid between $7,500 to $40,000 for trips down to wherever destinations that OceanGate had. And in 2015, OceanGate had completed its first custom-built submarine, which was the Cyclops 1 in this little photo here. This was the first submersible that they had that was controlled by the Logitech controller, and it was originally supposed to be made from carbon fiber. However, they later scrapped that idea in favor of steel. So next slide. In December 2016, they had plans to announce a Cyclops successor, and this was eventually launched in 2018 as the Titan submersible. The Titan was tested at about 400 meters deep, with a target operating depth of about 6,000 meters. There were also ambitious claims for future development and partnerships with NASA, as well as $18 million in development funds from inside investors, although NASA never officially acknowledged their partnership with OceanGate, as OceanGate wanted to use their facilities. To aid in funding, new tourism routes were added to OceanGate, and in 2021, Titan began its expeditions down to the Titanic. So can we move on to the next slide? So as for how the Titan submersible works, as we all know, the hull was made from a filament-wound carbon fiber reinforced epoxy, and this was used so the sub would be as neutrally buoyant as possible, and all the sub really needed to use was to dive and resurface with ballast weights and diving thrusters, and this was done to expend as little energy as possible. In an emergency, though, the sub could drop its ballast weights and rise up from the depths of the ocean without any power at all. However, we will see later why the carbon fiber was a bad idea. The two end caps of the sub were made from titanium, and one of them had an acrylic viewing window to see where the sub was going and just see the Titanic, obviously. Cameras were also located around the exterior of the sub to provide further spatial awareness, so the pilot of the sub knew where to control the sub. And there were 4 electric thrusters that control the submersible's forward, reverse, turning, and diving motions. And this was all obviously controlled by the Logitech PlayStation controller. So next slide.
OceanGate reported to have raised over $18 million for the Titan project. Originally, it was around 19.2 million, but the price was adjusted after a couple more accurate reports. Stockton Rush, the CEO of OceanGate, didn't reveal who the investors were, but he did state in an interview that the project was 100% funded internally. The seats for the Titan were originally offered to customers who wanted to view the Titan for $250,000 each. Jay Bloom, who's an American businessman, was personally offered seats by Rush for a discounted price of $150,000. And he offered these seats to both Bloom and his son. However, Bloom declined the offer out of safety concerns. And the recovery of the submersibles remains where it's also extremely expensive. The U.S. Air Force and the U.S. Coast Guard were both deployed, as well as Canadian forces. The U.S. Air Force and Coast Guard cost an estimated several millions of dollars of public funds, and Canadian forces, which consisted of 1 aircraft and several hundred sonobuoys, cost at least 3 million Canadian dollars.
Moving on to the personnel. The main person is Stockton Rush, who is the founder and CEO of OceanGate, and he led the vision, strategic direction, major decisions, and partnerships with University of Washington, Spencer Composites, and TI Fab. And Liz Taylor, who is part of the deep ocean exploration and research, warned against the carbon fiber use due to pressure challenges. And then there's Rob McCallum, who is a former consultant for OceanGate. He also raised concerns about rushed development and the lack of ship classification. The next person is Bart Kemper, who is a industry professional in forensic engineering. He criticized OceanGate's decision not to class Titan and emphasized adherence to engineering standards. And OceanGate claimed to have collaborated with NASA, Boeing, and University of Washington in marketing, but University of Washington clarified that there was lack of involvement in design, engineering, and testing. The same also goes to Boeing and NASA, stating that they were not direct partners in the Titan project, despite the Space Act agreement with NASA's Marshall Space Flight Center. Next slide. The ethics is OceanGate claimed partnerships with NASA, Boeing, and University of Washington in the Titan project, but these institutions said that they had no direct involvement, and it raised concerns about accurate representation, disclosure, and ethical responsibility in collaborative ventures. Despite concerns raised by experts and stakeholders, OceanGate decided not to pursue formal classification for the Titan submersible, and it reflected ethical dilemmas in risk management, accountability, and adherence to safety standards, and aligns with professional ethics, emphasizing safety prioritization, standards adherence, and transparent risk communication. Next slide. Continuing on with the ethics, after the incident, Titan's disappearance in 2023 raised questions about design integrity, operational safety, and regulatory compliance. And this includes scrutiny, reputational damage for OceanGate due to lack of formal classification, and potential design flaws. This also highlights ethical imperative of robust safety protocols, rigorous testing, and adherence to industry standards. There was lack of formal classification and design flaws that led to the scrutiny and potential legal implications. And with this serves as cautionary tales, emphasizing ethical responsibilities of organizations, engineers, project leaders, and transparency, safety, and accountability. And also highlights importance of quantifying consequences for understanding real-world impact of ethical lapses in engineering projects. The alternate actions that OceanGate should have taken were to collaborate with recognized ship classification societies like DNV for rigorous safety and design standards, increased safety for crew and passengers, reducing risk of catastrophic failures and accidents, and that they should show his commitment to regulatory compliance and adherence to safety protocols, alleviate concerns raised by industry experts and stakeholders regarding safety and design integrity, and that they should take time and financial investments, potential design modifications to meet stringent standards, regulatory oversight during the certification process, balancing safety objectives with project timelines and resource allocations. And by doing so, there's long-term benefits such as strengthened relationships with stakeholders, foster trust in OceanGate's capabilities and commitments, potential for long-term sustainability and success within marine exploration and engineering sectors.
David Lockridge, who was the former director of marine operations at OceanGate, presented issues that he found in the Titan's carbon fiber hull. There's namely issues with the material that would become catastrophic after sustaining immense pressure at the depths that they were going to explore at. But Lockridge was removed from the company after bringing up these concerns, which brings attention to like whistleblowing in general in today's society, which is extremely important for exposing improper practice and corruption in the workplace. But nowadays, it's not completely safe to be one, as we see with the recent Boeing whistleblower events, with 2 separate whistleblowers dying before completing their work. Josh Barnett died to a gunshot wound despite saying that he would not kill himself before fully pleading his case against Boeing, and Joshua Dean succumbed to illness despite being an extremely health conscious person. And investors for The OceanGate Titan were fully private, and the government did not have jurisdiction over the waters that the Titan was exploring, which means that OceanGate is fully responsible for the events that took place, and it's safe to say that the public does not trust the company as it used to. In conclusion, the OceanGate Titan failed due to a lack of conscious effort to fully ensure safety. There was a lack of proper classification for the submersible and blatant malpractice when it came to the integrity of the hull's material. The project on its own was expensive already, but recovery efforts for the submersibles remains cost millions of public funds for both the US and Canada. Future projects should absolutely be properly certified, and the hull material should always be rated for the depths expected to be explored. Because in general, Stockton Rush was a stubborn CEO. When it came to proper certification, he often cut corners, which in this case cost 5 lives. When people's lives are on the line, there is no such thing as being too careful.
Awesome. Great job, guys. All right, let's give our last group a hand. Awesome. And everyone give yourselves a hand too. That was a great set of presentations. Okay, so I guess this is a goodbye, I guess. So I mean, the last thing you guys have to turn in is just the final report. So make sure you guys are on top of that. So I'll open up. I don't think I've opened up the assignment yet for the final project or final report, but I will go ahead and do that probably early next week. And also remember that in addition to the final report, there is also a peer evaluation form or peer evaluation document that you have to upload as well. So, you know, the peer evaluation that's the last thing that you have to upload. That is an evaluation of how everyone else was able to hold up their end of the bargain, basically, right? Relative to your initial agreement of the shared responsibilities. So just reminding you, you know, I do take those evaluations into account, and so I do use those to adjust grades. And so, you know, if certain members aren't contributing, you know, I do take that into account when assigning your final grades for the project. So just, you know, make sure you guys are all working together and you guys are all on the same page, you know, for the last bit here. But yeah, I guess one more time, thank you guys for a great semester. Hope you guys all have a wonderful summer break. And maybe I'll see. I mean, I've seen most of you through advising as well, but you know, hopefully see you guys next year, and maybe in an elective course or advising or whatever. But yeah, thank you guys for being a great class, and I'll see you when I see you.
Thank you, Dr. Tran.
Thank you.
Thanks, guys.
Thanks for a good
Thank you,
semester.
Professor.
Thank
Thanks, Professor.
Have a good
Thank
one, Dr.
you.
Tran.
Thanks, guys.
Thank you, Professor.
Thanks, Nick.
Are you able to tell us our score?
I'm gonna look at the slides one more time, and then I'll give you guys your scores after that. So yeah,
What about a guesstimate of the score?
guesstimate. I don't do those, so I'll give you guys your scores tomorrow.
Okay.
Yep. Mm-hmm.
Hey,
Thank
Professor.
you.
Yep. Thanks, guys.
I have a quick question for next.
Sure. Yeah. What's up?
I think I'm enrolled in EGME 410 or
Okay.
infinite or the finite
Yep.
thing. What it's called exactly. Will you be teaching it next semester?
I usually do. I've taught it the last 6 times, but we do have a little bit of a wild card for next year. We are hiring a new faculty. She's actually already accepted the offer, and I've heard that she does have some background in finite elements. So usually when we hire new faculty, we let them kind of pick first in terms of what course that they want. And so if that's something that she's interested in, then she would probably teach that one. But if not, then I'll probably most likely be the one teaching it.
Hell yeah. Oh, and then also I was able to clear the requisite issue with the Cerritos.
Oh, good. Awesome. That's great.
But thank you again for the semester. It was an awesome class. And then I'll submit my or we'll submit the project and we'll see what I get.
Yeah, sounds good. All right, see you, Zaka.
Have a good one.
I agree. This was such a great class.
I'm glad you enjoyed it, Sarah.
My favorite this semester.
That's good. All right, have a good one, guys.
Thank you.
James, Jaime, any final questions before we sign off?
Oh yeah, I was gonna ask, So is office hours completely over? If I had any questions on like the report, should I just email you, or are you in the office next week?
I forgot. I'll send an announcement. I do have office hours next week. They're going to be at their normal time, so Monday, Tuesday, Thursday. But they're all going to be virtual. So
Okay.
yeah, I'll send an announcement after this.
All right, thank you. Have a good day. See
You
ya.
too. Bye.